powers of complex numbers. So let's say we have a complex number written in trig form, z equals r cis theta, and I want to find z squared. Well, this is not difficult. Z squared just means z times z. And we already know how to multiply complex numbers in trig form. Simply multiply the moduli together, r times r, and then add the arguments together, theta plus theta. When I simplify this, I get r squared as my new modulus and 2 theta as my new argument. Well, I can extend that to other powers as well. Z cubed would be z times z times z. So now I would be multiplying r times r times r, which is r cubed, and I'd be adding theta plus theta plus theta, which is 3 theta. And you can see the pattern forming here. Well, we call that pattern de Moivre's theorem. De Moivre's theorem simply says if you have a number r cis theta and you would like to raise that to a power, all you need to do is raise the modulus to that power and then multiply the argument by that number. So again, n becomes a power on the modulus and a multiplier on the argument. Well, let's try an example problem. So I have this complex number in trig form, square root of 2 cis 5 pi over 6, and I would like to raise that to the 4th power. What we've just learned from de Moivre's theorem is that I simply need to take that 4, put it as a power on the r, and put it as a multiplier on the argument. This then will become square root of 2 raised to the 4th power, cis, and then 5 pi over 6 times that number 4. Power on the modulus, multiplier for the argument. Let's simplify here. Root 2 to the 4th, of course you could do that on your calculator, although it's pretty easy to do by hand. If you multiply a couple of root 2's together, you get 2. These would also make 2, and 2 times 2, of course, would be 4. And then, let's see, 5 pi over 6 times 4. I can do some canceling here. Looks like I'm going to get 10 pi on the top, 5 pi times 2, and then a 3 on the bottom. So 4 cis 10 pi over 3. Now, this next part is very important. We like our arguments to be between 0 and 2 pi, no more than 1 rotation around. 10 pi over 3, that's 3 1/3 pi. That's more than 1 time around. So we are expected to simplify our answer by subtracting out extra multiples of 2 pi that we don't need. Specifically here, I can take 10 pi over 3 and I can subtract out 2 pi. Now I'll write it 6 pi over 3 so that I have a common denominator. That's just 2 pi. I can take that out. It's an unnecessary extra rotation. And so the final simplified answer, 10 pi over 3 minus 6 pi over 3, would be 4 pi over 3. Final simplified answer, 4 cis 4 pi over 3. That, of course, is the trig form answer. If I wanted the standard form answer, I would just have to write this out the long way and do the calculations. I would have 4 parentheses cosine 4 pi over 3 plus I sine 4 pi over 3. And 4 pi over 3 is a nice angle, so I can work these values out by hand. Maybe a quick picture would help me. Let's see, 4 pi over 3 is here in the 3rd quadrant. It's 240 degrees. My reference angle would be 60, and so I can easily make a quick triangle picture here. I'm going to have a bunch of negatives because I'm in the 3rd quadrant. Looks like cosine of 4 pi over 3 is negative 1/2, and sine of 4 pi over 3 is negative root 3 over 2. I'll finish off by distributing the 4. Half of 4 would be 2. I do have a negative sign there. I can see this will also be negative, and this 2 down here will divide into the 4 twice, leaving me with 2i square root of 3. And so this would be the standard form answer. Okay, let's try another one. Now imagine working this one out in standard form. It can be done. You'd have a whole bunch of FOIL problems. You'd take a couple of them, FOIL them out, get an answer, multiply by another one and another one till you had all 10 multiplied in. It would take a long time. Watch though what happens when we convert to trig form. Now the first thing I'm going to have to do is figure out what the trig form is for the number root 2 plus I root 2. I would be in the first quadrant. Root 2 would be the real part. Root 2 is also the imaginary part. I need to figure out the modulus r and the argument theta. Well, this is pretty simple. Do you see that I have an isosceles triangle, meaning the two legs are the same length? That means the theta, of course, is just 45 degrees. This is a 45, 45, 90 right triangle. The hypotenuse of a 45, 45, 90 is just square root of 2 times as much as one of the legs. We've used that result many times, and that comes out to just be 2. Of course, I could have also just used the Pythagorean theorem to figure out the modulus. So that means my trig form is 2 cis 45 degrees. That's what I'm wanting to raise to the 10th power. Well, I'm not going to have to do anything 10 times. I can just go straight to de Moivre's theorem, which tells me simply take 2 to the 10th power and then multiply the 45 by 10. And then that works out to be 1024, 2 to the 10th is 1024, cis 450 degrees. Remember, we always simplify our angle, our argument. We don't want to go around more than one rotation. So I have an extra 360 degrees in there that I don't need. I'm going to subtract out that 360. 450 minus 360 gives me 90 degrees. And just like that, I'm done. Here is the final trig version of the answer. If I want to go back to the standard form, all I would have to do is write this out. 1024 cosine 90 plus I sine 90. That's very easy to work out. 90 degrees, top of the unit circle. We know that the cosine value there is 0, and the sine value there is 1. And so this works out to simply be 1024i. De Moivre's theorem and trig form provide a very fast way for raising complex numbers to powers. Thanks for watching.